Okay, so for these first ones, you can see that we're giving the chemical formula and we have to come up with a name for them. So remember, the first thing that you really have to think about here is it ionic, is it covalent, or is it an acid? So sometimes it might even be beneficial before you even start to go through them and identify them. So for example, I might look at number 1 and go, oh, those are 2 nonmetals. So I'm just going to put a little C on the side, and that tells me it's covalent. As soon as I see a metal in the front, sodium, lead, something like that, I know those are ionic. So that one's an I, that one's an I. And in general, remember that when you see an H in the front, that tells you it's an acid. Okay, the only time you got to be careful with that is actually right here. And let's go ahead and do that one. Yeah, you can call H2O just water if you want. Okay, so if you see nonmetals, just nonmetals in there, like these ones here, those are going to be covalent. Covalent. When you see an H in the front, again, unless it's water, it's an acid. So that might be a good way to kind of help you get started. And now that we know, for example, on number 1 that it's covalent, now we know, oh, when it's covalent, I have to use prefixes. So CO2 is carbon dioxide. Okay, but when it's ionic, you never use prefixes. So be really careful with that. That, for example, on number 2, don't use mono-di-tri because that is an ionic compound. So NaClO3, because it's ionic, is sodium. And now we go to our ion sheet, or our notes that has this in there, and ClO3 is the name, or is the formula for chlorate. Oop, not chlorate there. Okay, so NaClO3 is just sodium chlorate. Okay, SBr6 is covalent, so we're going to need prefixes. So that's sulfur hexabromide. Okay, and now we've got an acid. Now remember, with acids, it's either a binary acid or an oxyacid. If it has oxygen in it, then you don't put hydro in the front. So this is nitrate, so nitrate becomes nitric acid. So HNO3 is just nitric acid. Okay, number 6 is ionic. It's got a metal in the front. Pb is lead, and lead is in that transition metal area. So notice I leave myself a little bit of space there because I am going to need a Roman numeral. Okay, fluorine has a -1 charge, and there's 4 of them, so that's -4. So that means the lead has to be +4. So that's an IV, lead IV fluoride. Okay, number 7 is covalent. So we're going to go tricarbon octahydride. Okay, and I will tell you on these especially, you look some of these up online, that's not the name they're going to tell you. They're going to tell you that C3H8 is called propane. Okay, 2 different ways of naming things. Make sure you're using the one that we have learned in class. Okay, HNO3, looks like I messed up. Looks like I did that one twice. That one is still nitric acid. Okay, let's kind of go through these ones again. Covalent, covalent, ionic, covalent. And again, I'm basically looking at the first element. If the first element is a metal, like in 11, then I know that it's ionic. If the first element is a nonmetal, then I know it's going to be covalent. If it starts with an H, unless it's water, it's an acid, 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 ionic, acid, and we'll go to number 18 there. Okay, and so number 9, because it's covalent, that's going to be diphosphorus pentaoxide. Number 10 is silicon dioxide. That's what sand is made out of. Number 11, be careful on this because that O2 kind of gives you a hint. Look in your notes. What's O2 with a -2 charge is peroxide. So this one should be called potassium peroxide. Okay, and then oxygen difluoride. It's covalent. Now we're back to some acids. So again, with no oxygen there, then we do have to put hydro in the front. So this one is hydrosulfuric acid. This one, again, no oxygen, so it's hydrochloric acid. But now we're back to one with oxygen. So this one is just sulfate becomes sulfuric acid. Okay, and then looks like I did the same one again. Sulfuric acid on number 17. On number 16, copper is a transition metal. That is going to require a Roman numeral. So this is copper, and hydrogen becomes hydride. And because hydrogen has a plus or a minus 1 charge, copper, to cancel that out, must have a plus 1 charge. So that's copper 1 hydride. And then number 18, SF4 is covalent, so that one is sulfur. And then the Roman, or not the Roman numeral, the prefix for 4 is tetra. So that's sulfur tetra fluoride. Okay, and then again, let's just kind of do these last ones here. Acid, 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 covalent, covalent, ionic, and acid. Okay, so number 19, it's got oxygen in it. And again, usually when it has oxygen in it, you got to go and look in your notes and look at those polyatomic ions that are there. Okay, the name of C2H3O2 is acetate. So that becomes acetic acid. H3PO4, this is called phosphate. So this is phosphoric acid. And now we don't have the oxygen there. So this is, again, hydro in the front, fluoric acid. And then back to some covalent ones. Carbon monoxide. Notice I don't put the double O there. It's not monooxide. When you put 2 O's together, take one out. Carbon monoxide. Okay, this one would be dinitrogen, also monoxide. And then we've got iron, transition metal, and carbonate. And then I go and look, what's the charge on carbonate? Oh, it's -2. So to cancel that, the iron also has to be +2. And then our last one, chloric acid. Okay, it's got an oxygen, so no hydro in the front of it. Chlorate becomes chloric. Okay, and that would be those first 25. Okay, for the next 25, these ones are usually pretty straightforward in terms of what type of compound they are. Obviously, if it says acid at the end, it's an acid. If it starts with hydro, you know there's no oxygen in it. So it's just iodine and hydrogen. So iodine has a -1 charge. So you need just the 1 hydrogen to cancel that out. So that would just be HI. Okay, carbonic acid does not have a hydro in the front of it, which means it has oxygen, which means you need to go to your notes, and carbonic comes from carbonate, and carbonate is CO3 2-, so we need 2 hydrogens to cancel that out. So that's H2CO3. Okay, and then we see a prefix here, so we know that's just P, and then Br, and then the 3. Okay, no prefixes here, and it doesn't say acid, so this one has to be ionic. So calcium is +2, fluoride's -1, so it's just CaF2. Hydronitric acid, so we know it's an acid. It's going to start with H. It has hydro in the front, so no oxygen, so it's just nitrogen, and nitrogen has a -3 charge, so it's H3N. And then same thing here, hydrosulfuric acid. Sulfur has a -2 charge though, so it's just H2S. With phosphoric acid, no hydro in the front, so we know that that has to have oxygens in it, so that comes from phosphate. So phosphate is PO4 3-, so that becomes H3PO4. Number 33, rubidium carbonate. Rubidium on the periodic table, it has a +1 charge. Carbonate is CO3 2-, so when we write that chemical formula, we're going to bring this 2 down here. So it's Rb2CO3. Okay, chloric acid. Chloric acid does not have a hydro in the front, so it has oxygen in it. So it comes from chlorate, and chlorate is ClO3-, so it's HClO3. Okay, and then 35 disulfur is S2. Hexachloride would be Cl6. Number 36, oxygen monofluoride means one fluorine, so the letter O and then the letter F is all you would have to do on that one. Number 37, mercury 1 sulfide means the mercury has a charge of +1. Sulfide comes from sulfur, and sulfur has a -2 charge, so that's Hg2S. Number 38, nitrogen trihydride means 3 hydrogens, so that's NH3. Beryllium chlorate. Beryllium is +2. Chlorate is ClO3-. So this 2 is going to come down here, so that's BeClO3 2. Carbon tetrachloride. Tetra means 4, so that's CCl4. Hydrophosphoric is H3P. Again, with hydro in the front means no oxygen, means it just comes from phosphorus. Phosphorus has that -3 charge. That's why we need the 3 hydrogens in the front. Okay, iron 3 oxide is Fe3+, because that's what the Roman numeral is. Oxygen is always 2- unless it's peroxide. So we switch those two, we get Fe2O3. Number 43, chlorine triiodide is Cli3, just like that. Hydrobromic acid is just HBr. Again, hydro means no oxygen, so it's just bromine, and bromine's -1. Acetic acid, no hydro in the front, which means it has to come from your ions, which means it comes from acetate. Acetate is C2H3O2-, so it's HC2H3O2. Okay, number 46, manganese 4 means manganese has a +4 charge. Phosphide is phosphorus with a -3 charge. So that formula is going to be Mn3P4. And then 47, chlorine difluoride would be Clf2. Nitrogen monoxide is NO. Sulfuric acid is H2SO4. Again, no hydro in the front, so it has to have oxygen in it. So sulfuric comes from sulfate, which is SO42-. And so we need 2 hydrogens in the front there. And then our last one, nitrogen trifluoride. Nitrogen and then trifluoride means 3 fluorines. Okay, so those are those 50 writing formulas and writing names of chemical formulas. If you got all 50 of those correct, you're in excellent shape. And if you made a couple mistakes, obviously no big deal. Hopefully you learned by watching this video to figure out. And if there's still something that you're not quite sure about, just make sure that you let me know and we can talk about it.